Okay, folks, now we're going to look at conductors and insulators. But first, we're going to do a little review from the last section. So how would you create a negative charge? Right, something is negative because, I'm going to pause for a second, let you choose one of the three choices, the four choices up there. Add electrons, add protons, remove electrons, remove protons. Pause it and come up with your answer. All right, so how do you create a negative charge? Well, you create a negative charge by having more electrons than protons, and the electrons are the only ones that move, so we would add electrons, so that would be A. And then how would we create a positive charge? Again, pause it and come up with an answer. Right, and again, the only thing that moves is electrons, so things that are positive have more protons than electrons, so you'd have to remove electrons, so the answer would be C. All right, and now for the last three, say, is this an attracted or repulsion? Positive, positive. Right, so now pause and do all three of these, and then we'll come back. Okay, positive, positive is repulsion because light charges repel. Positive, negative is going to be attraction, so that's A. And negative, negative, again, light charges repel, so it would be repulsion. All right, so we're going to be looking at conductors and insulators today, and a little bit about lightning as well. All right, so insulators are substances in which charges do not travel easily. They can be moved, but they don't move easily. It takes a lot of work to move charges. Okay, some examples of this are glass, dry wood, rubber, plastic, things like that. Things where you tend to get a shock because that's where electrons will kind of build up. You typically don't get shocked because of a piece of metal. Now, the piece of metal might pull those electrons away from you that cause the shock, but they're not storing the electrons right off the bat. Right? Conductors are things that allow charges to move easily. And typically, conductors have loosely bound electrons. You may remember that from chemistry, that metals are good conductors of electricity because they have those free valence electrons. Right? And so the electrons carry or conduct the charge through the metal. And most conductors are metal. There are a few non-metals that are good conductors, like graphite. Most conductors are metal. Okay, now lightning. What happens with lightning? And lightning is still not completely understood, but generally it's understood that during a lightning storm, during a thunderstorm, an upward wind in the storm clouds pushes the rain and ice particles upwards, where they collide with other pieces of rain and ice. Right? When they collide, electrons transfer between those particles. Eventually, the top of the cloud usually becomes positive. I say usually because sometimes it becomes negative, right? But usually it becomes positive, and the bottom of the cloud becomes negative. Okay, and then sometimes, this is most of the time, but really some of the time, lightning hits the ground. Okay, but because lightning goes from high energy to low energy, sometimes the lightning can flow to another part of the cloud, like from the bottom of the cloud to the top of the cloud, and that's why sometimes you'll just see the sky light up and you don't actually see the lightning bolts because the lightning is just going from the bottom of the cloud to the top of the cloud. Right now, this is the example where static electricity takes a short path. So you see this airplane flying, it's just taken off, and you can kind of see it's doing it in a thunderstorm, and then it's going to come and a lightning will strike it. And notice that it goes straight through the plane and then continues on to the ground. And it helped. The lightning was helped by having the airplane in the way there. All right, so you might see a lot of buildings and such have lightning rods, and the reason they work is because if you have a lightning rod on top like this guy has here, what happens is it will slowly pull some of these electrons out of the clouds, slowly pull them down and allow them to come down. Whereas here, there's no way to dissipate the charges. So as the ground becomes more and more positive and the cloud becomes more and more negative, eventually you can have a lightning bolt come down, maybe hit the tree and burn that down. or hit the top of the house and burn that down. Whereas if you have a lightning bolt, there's a gradual release of the electrons. It doesn't allow the charges to build up, and therefore you don't have the lightning strikes. Or if there is a lightning strike, it'll strike there, and that's connected to the ground, which makes everything perfectly safe. All right, so our next topic will be types of charging, and we will do that in just a little bit.